I'll do the audio. Move, zig. For great justice. There we go. Cool. So it actually ends there, so we got the audio just in time. It's absolutely relevant to the talk, but I will use my speaker privileges if I'd like. I want to remind everybody, that's a thing, it exists. I'm here to talk about offline architecture and real-time design. At previous Develop Denver, I talked specifically about real-time design and some of those implications. Since then, I've grown really fascinated with the parallels between that and real-time specifically. So, if anybody caught Steve Kinney's talk today, workshop specifically, it was very hands-on, very in the details, light on the sales pitch and heavy on the implementation. Mine will be sort of on the opposite end of that. I'm not going to sell you anything, but we are going to talk about the architecture and design levels of some of the implications of offline technologies. I believe I have remote controllers. I want to make sure. Boom. I want to think first about when things go offline. I'm sure you've experienced before GoGo, and even with GoGo Wi-Fi on an airplane, when you don't want to pay, you're offline. Going overseas, especially, you're going to be offline in an airplane. I went to Develop Denver Unplugged as a part of like the pre-conference, and we went into the middle of nowhere, into the mountains, did some really cool camping, and we were wireless, but offline. There was no connectivity, at least with my network. I think there might have been a couple of people who had signal and were able to check Twitter. But I wasn't, and experienced, again, offline world of the web then. Sometimes you're offline when you run out of mobile data. You have a subscription plan, but you actually run out. It costs money to renew or add more data to your plan, and you're unable to connect. You go offline when the power goes out, or power goes out in a zombie apocalypse. Unlikely event, but if you're into that sort of thing, any form of apocalypse, you must expect that the internet's not going to stick around. In the underground, when you're catching a rail in New York City, the most common thing you'll see is somebody before they get into the bus, just like stopping like 5 minutes before they go underground into the tunnel to quickly do something on their phone, maybe take a screenshot of a Google map, or send a text to let someone know they're on their way. They're not going to be able to do any of that once they've gone 20 feet underneath several blocks of cement. It happens when the server is down. When you build an app that depends on the server being omnipresent and always available through a network, your customers, your users go offline when that's not available. It disappeared to them. In all of those scenarios, web software is useless, right? You know, imagine I told you 20 years ago that I was going to build a calculator or a spreadsheet for your mobile computer, and that there were certain conditions in which it would no longer work. You get on an airplane, this software this very expensive software I built, it was just going to be unresponsive. When you go underground, if you're on a camping site, you won't be able to use this app. I think there was a right context in which that's laughable. And today we've accepted it as a default, as a standard. We acknowledge that the internet is not guaranteed. At least I'm hoping we're starting to acknowledge that. Yet it's still unaccounted for. The reality of the web today is mobile, increasingly, and as a consequence, the reality of the web is intermittent connectivity. This word, by the way, I was writing the slides, it stops to look like a real word after a while. Error. I started to think of the Office quote of Dwight Schrute. He says that R is the most menacing word. That's why they call it murderer, not muck duck. Error, everybody. Part of mobile first, which is something that is more or less a standard today, is an acknowledgement that we're building for an unknowable number of screen resolutions. The philosophy of offline first starts with the premise that we're building with an unknowable range of connectivity. Given that we have a mobile web, people are moving from one place to another, the network is no longer a guarantee. So in short, the offline first approach treats web apps in a progressively enhanced way, in that you first assume that there is no internet connection, and then treat the network as an enhancement. This is very difficult to do starting after the fact. So I'm sorry to say that patching this isn't easy. So having an app that's not offline first makes it quite tricky to deal with, which is why it's called offline first and not necessarily offline later. This really needs to be baked into part of your design and of your architecture in order for it to be as easy as it can be. I think there's 3 categories of offline apps, and I'm going to talk briefly about each. The first, I would say, is traditional. A calculator on your phone, a spreadsheet on your desktop. These apps are synonymous with other forms of offline software that you can imagine. And certainly, in later years of the evolution of computers, the network did become an enhancement. We have now real-time applications like Google Docs and spreadsheets that do have the network as an enhancement. But then there's a second form of offline app that doesn't have that has a little bit more to it. So this would be an application that is offline because you can access it without a network, based on having already been there once and it caching some of its resources. News articles could be cached locally on your phone. A blog post could be cached locally on your phone. Spotify playlists, you have to explicitly do this when you're a pro subscriber, but you can download it and have it, access to it later. This is like a caching mechanism that gives you access to a feed of some sort. So this would be your cache category of web apps. The one that we're going to, and Ethan Marcotte, by the way, who in effectively invented responsive web design is starting to talk about this. And if Ethan's talking about it, I think it's time to start paying attention. They just make their personal website offline first. So you visit it, and it falls into the cache category, so you visit it once, and now you can re-reference it later. The third I would call synchronized or synced, in which the application goes offline, and you can access its data in a read format, the way that you can with cached applications, but you can also access its data in a write format, in that you can modify the data. The key to this type of application is that it works offline and can synchronize with other services later. A great example of this, and a great use case for this, is called Hospital Run. This is an application that helps doctors and social workers in third world countries where the internet isn't intermittent, it's almost unavailable. So they would go explicitly and travel explicitly out of their way to synchronize their servers, their local servers, their local cache, with every other base server, the home base, at some point in time. So they'd have to go out of their way to actually make that happen. So to quickly recap, we have the three categories of web apps that are offline. The type that were never meant to be online. For traditional apps, you've got the type that only cache data, pulled down locally, and then you've got the type that need to synchronize over time. In the latter category, the main advantage that I want to focus on today is how speed is a feature. We've seen from study after study that speed sells. We know that conversion rates are higher for websites that download quicker and have generally less latency in all the interactions from point A to point Z, your conversion point. And specific research illustrates that we actually have certain levels of tolerance for different amounts of time. I know we're not used to thinking in terms of milliseconds as programmers necessarily, but allow me to for a moment, in 100 milliseconds, doesn't matter what you're doing, if it only takes that much time, it's perceived as instantaneous to your users. There is no difference between 0 and 100 milliseconds. For 200 milliseconds, it starts to feel laggy, and that's actually surprising to me that that's all it takes is one more of the nothing amount of time. Just double the nothing amount of time, and you've got lag. After that, it feels sluggish at 300 milliseconds. I think that's pretty amazing for something to feel sluggish at 300 milliseconds. And finally, at 1,000 milliseconds, a mental context switch has happened for your users. So I use these points as a selling point for real-time design. What I want you to pay attention to, if you're familiar with it, and I'll point out in a few places where there are parallels between some of this offline architecture that we're going to look at and real-time web design. And it almost seems like they're antonyms of each other, right? If something's offline and real-time, or one or the other, they seem like opposite ends of the spectrum, but we'll see today that they're actually not. So in any application, unless you're doing it really, really poorly, the most latent part of your web application is going to be the network. Maybe your JavaScript has a memory leak and you're doing a lot of damage to other things that make other things take more than 300 milliseconds, but more likely than not, the thing that takes more than 300 milliseconds is going to be the network. And in the network, there's two terms, two vocabulary words I want you to keep in mind: latency and bandwidth. These together determine the time it takes to get something over the network from your server to your client. And latency, you could just describe as the time it takes for one piece of data to get from your client all the way to the server or back. That's just that amount of time. That's how latent something is. Then you have bandwidth, going up and down here. That's how much of that you can do at one time. This is a really broad topic. We're going to focus and narrow in on latency and specifically what's called latency compensation. How do we, this is the question and answers, how do we as developers and designers account for that latency, knowing full and well that more than 300 milliseconds is going to feel sluggish? Real-time web solves this problem, and I would argue also offline web solves this problem, as you see. Here's a traditional application architecture on the web. Not to be confused with like a traditional offline app that we talked about earlier. It's just like, probably what most of us ship for work today. You've got a server that delivers the application and a full app render for every page refresh. Every interaction gives you a new instance of that app rendered over the network. Okay, so I actually did have a reason to use that video earlier. So you are on your way to destruction using this model if you're trying to account for latency. Looking a little bit closer at latency compensation, this is sort of where it comes in to save the day. In the next slide. Cool. So to accommodate for a latent network, let's just interact with and store all of our data on the client side of the network, introducing some sort of system in which your application doesn't go over the internet. They load it at some point, and now all further interactions go back and forth between the application and the browser storage, for instance. That's fine and all. You know what you're doing, but you still need to be able to connect to the network. And that's where we would introduce some sort of synchronization layer between the browser storage and the server. So a common approach is to use something like PouchDB and CouchDB, where PouchDB is a in-browser NoSQL database that actually has a built-in synchronization layer to connect it to a backend API. So the idea here is that the user can interact with the application, they can write a new comment on something, and it doesn't need to go over the network right away. Its first step is in the phone. There is no latency, so your application could accept the data into its local storage and update the view accordingly, never having consulted the network. And in this scenario, at any point the network could have gone down. Your application could have gone offline, your user could have entered a subway, the apocalypse could have happened, and the network's failure, and that however long it takes, is irrelevant because the user can communicate still with their database. They can add comments, they can modify content. A great example of how to handle this would be Slack or Trello. When you go offline, they account for you having gone offline and present it in a unique way. So we'll talk about the challenges of an offline architecture later. That's one of them for designers, which is new UI elements that you maybe haven't considered, you haven't really considered where their home will be in your software until now. So this is how it looks when it goes offline, but then we get signal. And when the network comes back on, it persists then over the network to the database. The user could be none the wiser. We could have done this all behind the scenes and everything felt instantaneous. In this model, there is a challenge. Notably, the user was offline for some amount of time. And as such, the data that they had cached could have changed on someone else's phone. You'll see in another slide, but you're in the distributed systems business now. As soon as you introduce an element where a user can go offline for some amount of time and then hopefully persist their data later, there could be merge conflicts that you have to deal with. But hopefully you have something like CouchDB, which could help with that. Back to the model that everyone's more familiar with, an application that's rendered in the client and makes every request over the server. I want to show how this scales up. So when you have multiple users accessing your server, you can see they have you have multiple app instances existing on the other side of the network, and if any one of them lose network connectivity, it's actually not that bad. At least in terms of your system's uptime. It won't affect you if the first app that connected gets disconnected by mistake at some point. But somebody set us up a bomb and our server crashes. In that scenario, you end up with every client unable to access or use your app in any meaningful way. So if you think about that for a second, and how often it actually happens, if Amazon Web Services go down, or you shipped a bug to your system, or you accidentally gave the newest person on the team production access and they shipped their branch to master, like, it happens. And if we re-architect things with an offline first approach, it doesn't phase any of your users for your system to be down on your end for any reasonable amount of time, provided that they each are able to still use the application in a meaningful way, persist any new data that they provide, and rely then on eventual consistency when the network turns back online. There are a couple things to consider besides just latency compensation when we're talking about performance, and I want to show how an offline architecture actually gives you all of the possible gains. First is to reduce or to defer round trips to the server. So in order for your view to update, in many applications we depend on either a full page refresh, which is a round trip to the server, or an AJAX request, which is a round trip to the server. Web sockets might be a little bit more responsive than each, but again, if the network is down, you're still taking a risk every time you send data over the wire. And in this model, we've got the data posting immediately to our browser storage. There is no risk in that. You're guaranteed its storage, and then the view can update immediately. You're also looking at moving data closer to users. Maybe you're familiar with CDNs and the advantages that come with it. The idea being that if I put my stuff on a server that is closer physically to where someone is loading the application from, then the round trip that the data has to make is a shorter distance in real space, so it's going to load faster. If you take that reasoning to its logical conclusion, again, loading, persisting data immediately to the local version of your database is the closest you could possibly store the data. It's literally on their device. And also, we're looking at caching the data. Again, there's not so much concept of caching if it's just kind of its default. So you're defaulting to the cache, so to speak. There are unique challenges to offline, specifically in way of user interfaces. Notably, we want to indicate at some point whether or not the data that users are entering into our system are going to persist right away or persist later. In many use cases, that could be relevant. We might even change UI elements like the save button. Slides.com, which I'm using to host these handcrafted artisan SVGs, has a really great save mechanism. It's a floppy disk, which seems antiquated, but it spins and then becomes a check mark occasionally, kind of letting me know that in the background it's saving, even when I've made changes locally that aren't necessarily represented on the server. It's an interesting question to me. How do we communicate then the network status? Do we need to in our use case? How long should you cache data locally? Should it be forever until we fill up the user's device with all of our web applications cached, locally stored data? Or is there some point at which we should erase it all? Another challenge that introduces whether or not you give the user that control and how you might communicate it if you do. Because they're not necessarily thinking of having the device maintain their storage instead of your server maintaining storage the way that we would. So there are really unique challenges still in the space. I want to point out, check out Alex, I'm going to slaughter the name, Fader's talk on offline first, and the high performance browser networking. It's an O'Reilly book, but it's published online completely free. I'm going to post these, I'll tweet them very shortly, some of the references for the talk. This is the obligatory, I work at a company called Healthify. We're not always hiring, but we are currently hiring for software engineers and product designers. It's a remote, distributed team, for-profit, socially good company doing really cool stuff in the healthcare space. Check us out and talk to me afterwards if you're interested. Thank you. I'm Aaron.